Mercury. Mercury is the closest planet to the Sun, but if you think that means it's hot all the time, you're wrong. At night, temperatures can plummet to an icy -180 degrees Celsius. During the day, however, they can skyrocket to 430 degrees Celsius. This extreme imbalance happens because Mercury doesn't have a proper atmosphere to regulate temperature. Instead, it has a very thin exosphere which doesn't maintain heat. While you wouldn't have to worry about weather on Mercury, the real dangers come from solar radiation and the lack of breathable air. In fact, Mercury gets almost 7 times the solar irradiance that Earth receives. As the smallest planet in the solar system, Mercury is full of craters, cliffs, and bumpy terrain, making it a tough place to land. The low air resistance doesn't help either. It makes slowing down a spaceship much harder, increasing the chances of a high-speed crash landing. Landing during the daytime is out of the question because of the extreme heat. NASA's latest spacesuits can only handle up to 121 degrees Celsius, nowhere near Mercury's daytime temperatures of 430 degrees Celsius. Nighttime isn't much better. Temperatures of -180 degrees Celsius far exceed the lower limit of NASA's suits, which is -157 degrees Celsius. Your best bet would be to try landing in the Terminator zone, the area between day and night where temperatures are more moderate. Even there, however, conditions can be risky since temperatures change relatively quickly. Venus. Venus is the closest planet to Earth, sitting just 40 million kilometers away. This means the journey would be relatively short, about 4 months. Its size and gravity wouldn't pose much of a problem, since they're pretty similar to Earth's. The first real issue you'd face, though, would be the thick yellow clouds you'd see as you approached the surface. Unfortunately, they're made of sulfuric acid, a highly corrosive substance that would destroy your lungs in seconds. Assuming you had a suit advanced enough to filter it out, visibility would drop drastically as you descended. The atmosphere is incredibly thick and made mostly of carbon dioxide, making it hard to see. Then comes the heat, an unbearable 450 degrees Celsius. Only about 10% of sunlight reaches the surface, so it would be pretty dark. Even though gravity is close to Earth's, the air is so dense you'd feel like you were wading through a heavy liquid. With a good pressurized suit, you might last a few seconds, but the atmospheric pressure, about 92 bars compared to Earth's 1 bar, would eventually crush your suit. If that didn't kill you, the sulfuric acid you'd start breathing once the suit failed definitely would. Mars. Mars is the second closest planet to Earth and the most habitable of the 8 planets. Daytime temperatures are much less extreme compared to Mercury and Venus, reaching up to a relatively comfortable 20 degrees Celsius. The real challenge comes at night or in colder regions, where temperatures can drop as low as -130 degrees Celsius. Like Mercury, Mars has a very thin atmosphere, made mostly of carbon dioxide with only trace amounts of oxygen, meaning very little breathable air. The thin atmosphere also results in low pressure and high radiation exposure. The average radiation level on Mars is 24 to 30 rads, about 40 to 50 times higher than Earth. On top of that, Mars experiences frequent and violent dust storms, with wind speeds reaching up to 100 kilometers per hour. These storms pose serious challenges, so any attempt at habitation would require a sustainable, airtight, and well-insulated life support system. Jupiter. Jupiter is the biggest planet in the solar system and one of the hardest to land on, primarily because of its extreme radiation levels. Even 300,000 kilometers away, the radiation would penetrate your suit. But let's assume you had a hypothetical suit that could block it. Jupiter's gravity is 2.4 times stronger than Earth's, so you'd fall incredibly fast. Entering the first layers of the atmosphere, you'd encounter white clouds made of frozen ammonia crystals at around -150 degrees Celsius. Winds here are extreme, reaching speeds up to 482 kilometers per hour. After descending about 150 kilometers, you'd reach the deepest point NASA's Galileo probe ever explored in 1995. Beyond that, it gets darker and both temperature and pressure rise rapidly. Near the core, the pressure is estimated to be 100 million times Earth's atmospheric pressure. Hours of falling would eventually bring you into layers of supercritical fluid, a strange state between liquid and gas. Further in, you'd find metallic hydrogen, an incredibly dense liquid that would trap you. If you somehow passed that, you'd reach Jupiter's core, though it's unclear if it's solid. Temperatures there could reach about 24,000 degrees Celsius, 4.5 times hotter than the Sun's surface. Saturn. Saturn is the second largest planet in the solar system, with an atmosphere mostly of hydrogen and helium. One challenge would be avoiding a collision with its 146 moons or its massive rings made of ice, rock, and dust. Assuming you made it through, you'd witness stunning red and purple auroras caused by highly energetic hydrogen. But Saturn's atmosphere is brutal. Hurricane-force winds reaching 1,800 kilometers per hour make it nearly impossible to stay steady. At the North Pole, a massive storm big enough to fit 2 Earths rages constantly. The upper atmosphere has ammonia clouds and temperatures dropping to minus 250 degrees Celsius. Deeper layers eventually warm back to 0 degrees Celsius, but pressure becomes extreme, rivaling the deepest parts of Earth's oceans. Going further, gases transition into liquid, and if you survived, you'd reach a molten rocky core about 10 times Earth's size. Temperatures there soar to 11,700 degrees Celsius, with pressures 1,000 times greater than Earth's. Uranus. Uranus is one of the 2 ice giants and the only planet that spins on its side. It rotates faster than Earth, with a day lasting just 17 hours. Being an ice giant doesn't mean it's made of solid ice. It's mostly composed of elements heavier than hydrogen and helium. After avoiding its faint rings, you'd encounter toxic gas layers where temperatures plummet to below minus 220 degrees Celsius, making it the coldest planet in the solar system. Descending further, you'd be battered by ice pellets and face hurricane winds of up to 900 kilometers per hour. Eventually, you'd encounter one of Uranus's most unique features, diamond rain, formed under extreme pressure. But the pressure here, about 100 times Earth's, would ultimately crush you long before you could enjoy the view. Neptune. Neptune, the second ice giant, is very similar to Uranus. It's the farthest planet from the Sun, 30 times farther than Earth, making it incredibly dark and cold in its outer layers. However, inside, immense pressure keeps the inner layers intensely hot, with the core reaching around 7,000 degrees Celsius, hotter than the Sun's surface. Like Uranus, Neptune experiences diamond rain due to high pressure breaking down methane. Its winds are some of the strongest in the solar system, reaching supersonic speeds. In many ways, it's Uranus's twin, but harsher and even more violent.